Greetings, Dr. Dan with Optimal Optics, here to introduce Unit 10P, word problems about spectacle lens prism effect and vertex distance. I'm assuming you have already viewed the video on Unit 10, which would be very helpful in order to answer these questions. Question 1, a +1 lens is moved down 10 millimeters from the optical axis. What prism power is induced? So the formula is prism power equals HF. H is the decentration in centimeters, so it's 1 centimeter. Power of the lens is 1, so we find that the prism power is 1 prism diopter. To figure out which way the base is, you have to realize if the lens is moved down, you're looking through the top half of the lens, which means the base of that prism is down. Question 2, a marvelously myopic individual requires -10 diopter spectacle lenses at a vertex distance of 15 millimeters. What contact lens power may we expect? And round your answer to the nearest half. So the focal length of the spectacle lens in millimeters is 1,000 divided by -10, which means it is -100 millimeters. For the purposes of answering the question, we're going to make that a positive number, and the focal length of the contact lens will be 100 plus the 15 millimeter vertex distance, which is 115 millimeters. Now we convert that to a negative number because the power of the contact lens will be negative, and we find that the power equals -8.7 diopters, so we'll round it to -8.50 diopters. If we draw it out, you'll see why we added those two numbers, 115. There's an eyeball, cornea to the left. There is our lens. It's a minus lens, so it's drawn with the inverted arrowheads. There is our secondary focal point, which is 100 millimeters from the lens. The vertex distance is 15. You add them up and you get 115. Question 3, what is the prismatic effect of a lens of power +4 diopters decentered 7.5 millimeters? So again, formula is P equals HF. H is in centimeters, so it's 0.75 centimeters. Power is +4. We multiply them and we get the prism power equals 3 prism diopters. Question 4, if an individual wears a contact lens with a power of +6 diopters, what eyeglass power is expected at a vertex distance of 15 millimeters? So up to now, we've changed spectacle lens power to contact lens power. We're doing vice versa now. If you can answer this, you really have a good understanding of the material. I urge you to pause the video and try it yourself. Draw it out before you write down your numbers. So remember that the absolute value of the focal lengths of a lens are the same. For a plus lens, the primary focal length measured from big F to the lens is a positive number, and the secondary focal length measured from big F prime to the lens is a negative number. For the purposes of this question, we're going to make everything positive. There's our spectacle lens. And we find that the focal length of the contact lens, which is that blue arc that I drew on the cornea, that equals 1,000 over 6. It's 166.67 millimeters. So that is the value we are assigning to that distance, a positive value. Now we see we have to add the 15 millimeter vertex distance of the spectacle lens to get the focal length of the spectacle lens. And that equals 166.67 plus 15, it equals 181.67 millimeters. So the power of the spectacle lens equals 1,000 over 181.67, and it equals plus 5.5 diopters.